this is the start of Unit 11. We're going to start talking about linear equations, which this will get you ready for Algebra 1 for next year. It'll give you a pretty good head start. So we're going to start off, this would be considered page 2 in your notes packet. It's called Slope Day 1 on a Graph. We're going to start off with our prior knowledge of crazy K. And we know that crazy K is in fact a unit rate. And we also call it our constant of proportionality. So if you remember, to be able to find crazy K, we are doing y value divided by the x value. And we actually learned that we could write an equation then of y equals kx, where we replace that k with the actual number value that we have here. So we have two examples for you here. In this first one, I have oranges on the x-axis, ounces on the y-axis. And I do note that there is a point right here that actually goes through the grid, so it's easy to read. My y value here is 2. My x value here is 1. So to get my k value, I'm going to do the y value divided by the x value. So 2 divided by 1 is 2. And if I were to put a label on that, I would do the y label per the x label. So ounces per orange then would be our k value here. We could also write the equation of this line. It's y equals kx, and since k is 2, we would say this equation is y equals 2x. If I look over here, Damon has written his own recipe for pot roast. The graph shows the proportional relationship between the weight in pounds at x and the total cooking time in hours y. So go ahead, take a second here. What would your k value be on this graph? So looking at this point that they actually labeled for us, to get k, we would do y divided by x, so 1 divided by 2, and that's just a half. And if we were to give labels to it, we would put hours per pound then. What would the equation for the graph of this line be? So our equation here would be y equals 1/2 x because we're following y equals kx. We're going to be moving into linear relationships, and we actually just saw two examples of linear relationships, but linear relationships, they form a line. And you can see that word line starting off the word linear. So in forming this line, we have to realize a couple things. These are not always proportional. So the last two examples that we saw were proportional relationships because they were a straight line and they were through the origin at 0, 0. However, the majority of the lines that we're going to see are not going to be proportional. So since they are not proportional, they don't have a k value that's going to be the same in every point on the line. Instead, what they have is called a constant rate of change that's going to be similar to k, but it's not the same thing as k. This constant rate of change is actually called slope. So the slope is the rate a line goes up or down, and it is a ratio that compares vertical change, and vertical is up and down, to horizontal change. And horizontal would be going from side to side. Slope, we are going to utilize the letter M to represent slope. And we're going to start off today by using slope defined as rise over run. Rise is going to represent your vertical change, and your run is going to represent your side-to-side change. A couple things about slope that you need to know. We are always going to represent slope as a fraction. We are always going to make sure that the fraction is reduced. We are always going to leave it improper. And we are going to make sure that when we do slope, it is just our number and there are no labels. So these are 4 important facts about slope. Leave it as a fraction, make sure it's reduced. If it's necessary, leave it improper and make sure there are no labels with it. When we take a look at this treadmill, we can actually define the slope of the treadmill. We can look at the rise, which would be the up and down vertical change of 10. and compare that to the horizontal side-to-side change of 48. You do need to reduce this. Remember, our slope is always going to be a fraction and it needs to be reduced. When we reduce, we get 5/24. So the slope of this treadmill is considered 5/24. Let's take a look at what this looks like on a graph. So we're on to the next page now. We are going to create on this page what are called slope triangles. We are always going to start at the left side of the line. So we are going to take a look at this graph and note that there are 2 points that are actually marked for us here. As I just told you, we're going to start at the one that's further to the left. Left is here, right is over here. So we're going to start on this blue dot down here at the point 0, -3. From here, we're going to look at our rise. So we are going to just draw a line, and this might be useful to get a highlighter or a marker or colored pencil at this point to do this. We are going to draw a line up until we reach the y value of the other dot. So I'm going to draw it up to this 1 right here. So that's going to be the start of my slope triangle. I'm actually going to switch to a highlighter here just so you can see this a little bit better. From there, we are now going to travel to the right to get to our other blue dot. So when we travel up, that is a positive movement. And that should make sense. We're going up the number line, that's positive. When we travel to the right, that is also considered a positive movement. Vice versa, if we travel down or to the left, those are going to be considered negative movements for us. So when I go back here to my graph, I'm going to now count the distance that I traveled up. So I'm going to count them in terms of blocks. This counts as 1 space, 2, 3, and 4. I'm going to mark this with a positive 4 because I moved up. From that spot, I moved 1, 2 spaces to the right, which is also a positive movement. Our slope here, we're going to take our rise number, which was 4, and put it as a fraction over our run number, which is 2. When we reduce 4 over 2, we actually just get the number 2. Slope can be represented as a whole number, and if the fraction reduces to a whole number, your slope should be written as a whole number. We would not write this as 2 over 1. We would just write it as 2. Starting over here at this one, I'm going to pick my line or my dot that's down in the left-hand corner. To get to this one in the right, I need to travel up. So that's going to be a positive movement. And I'm also going to be traveling to the right. That's also a positive movement. Go back and count. 1, 2, 3, 4, 5, 6, 7. From here to the right, 1, 2, 3, 4, 5 spots on the graph. Slope can also be identified as the letter M, so I'm going to start to use that now. So we're going to do M equals. Your rise was 7, your run was 5. This is already reduced. There's no common factors, and it is already an improper fraction, so we're going to leave it that way. We will not be changing it to a mixed number. In our next 2 examples, we're going to start at the left and work our way to the right here. So from the left, I need to travel up 1, 2, 3 spots. And then I'm going to travel to the right. 1, 2, 3, 4, 5 spots to the right. So again, these are both positive moves. My slope is going to be rise of 3 over run of 5. 3/5 is already reduced, so slope is 3/5. In this next example, my left is up here, my right is down here. So moving from the left, I'm going to actually have to travel down 1, 2. Remember that moving down is a negative movement, so this rise is a -2. I'm going to move then to the right, 1, 2, 3, 4, 5, 6, 7, 8 spots to get to that dot. I move to the right, so that's a positive movement. Here, my slope is rise of -2 over run of 8. This does need to be reduced, and when I have a negative, I'm going to actually write that out in front. So I'm going to put negative 1/4. Doesn't matter if the negative happens with the rise or the run. When you're reducing and writing your final answer, the negative will come first. And the next one, I'm going to start here and move down to here. So that's a rise of 1, 2, 3, 4, 5, 6, 7, moving downward. So that's a negative 7. From here, I need to move to the right to get to my dot. 1, 2, 3, 4. Moving to the right is positive. My slope is negative 7/4. That is reduced. It is improper, so that's good to go as my answer. In this last example, I'm going to have you count from this dot to this dot. First question, what is your rise? We're moving downward here, so we're moving down. 1, 2, 3, 4, 5. Your rise is a negative 5. What would be your run? You're moving to the right here. 1, 2, 3, 4. So that's a positive 4. Your slope then would be negative 5/4. And again, we're going to just leave that. It already is reduced. It's improper. We'll leave the negative out front. And that's it for your first lesson on slope on a graph.